Hi guys, this is Andrew. I'm one of the practicum students as with your class for this semester. Today I'm going over arithmetic sequences with you. This is one of the Algebra 1.5 lessons. It's from week 8. I'll be going a little bit over some of the homework problems and some example problems. Start off with the objectives for today and for this chunk of the week as a whole is to determine if a sequence is arithmetic, and if it is, to find the common difference. Um, Additionally, we want to find the next term of any one of these sequences as well as the nth term for that same sequence. So to give you guys a little bit of a real world example, this is just a hockey score I pulled from, I want to say it was on Sunday maybe. The Nashville Predators um, ended up scoring a 1 goal per period, and which ended up making a running total of having 1, 2, and then 3 for a total of 3 goals in the game. I don't believe they won this game. But I guess I just brought it up so you guys could notice that there is a consistent pattern in the scoring from period to period, and start to just relate to what that would make you think of, and then how that relates to the topic we'll be talking about a little more today. Well, what is an arithmetic sequence? Well, to answer that question, we'll just go to its definition. An arithmetic sequence is a sequence of numbers where consecutive numbers have a constant difference, which is also known as a common difference and denoted as D. We'll be using the term common difference in this class rather than a constant difference to refer to that. And just remember that that is denoted with the variable D. If we look below here, we can see a little bit about what this is all about in practicality. So this top row of turquoise numbers is the position of the number in the sequence. So we have position 1, 2, 3, and 4. Those are kind of like the order of this set. So this is the first number in the set, the second, third, and fourth. So then when you apply those into the sequence and you find out which number is the first number in the sequence, and then what number corresponds to that, you find it's 5 in this sequence. So 5 is our first term because it's because there's a number 1 attached to it, and then 8 would be the second term, 11 is the third term, 14 is the fourth term. And then just a little bit more on the terminology here. So you see below we have these A's with these little turquoise numbers on them. This means A sub, and then it's the number that's here. So this is A sub 1 is also known as 5. And then A sub 2 in here is 8, and so on and so forth. So this is kind of just the way we denote. So in this sequence, we could say that A sub 1 is equal to 5. So now to get into an example from class. This first example we're going over is adjusting those first two objectives where we find a common difference by first determining if the sequence has that, and then if it does, it would be arithmetic. And then if a sequence has that, we can then find the consecutive 3 terms that would follow the last term we are given. So if you see here, our step 1, the first step in completing one of these is to find the value of D, or the common difference, by subtracting consecutive terms. So if you look down below, we have 2 sequences here, sequence 1 and sequence 2. So sequence 1 is the numbers in order -2, 2, 6, 10, 14, and then it has these 3 little dots at the end, which means that it just continues on for however long. This could technically have ended right here, but for our case, we'll just say this keeps going on. So what we need to do first is, again, we're going to do the step 1. We want to find the value of D, or the common difference, by subtracting consecutive terms. So if I reveal this first thing here, we'll see the differences here in this column here. So what you'll do is you'll take the second term and subtract the first term. So in this case, we'd have 2 minus a -2, which becomes basically one big plus, which I will write out for you to see here. this basically just becomes one big plus here, so it's 2 plus 2, which is equal to 4. And then in the second one we do 6 minus 2, which is equal to 4 again, and then 10 minus 6 is equal to 4, and then 14 minus 10 is equal to 4. So then we will talk about what we're supposed to do with that in just a moment. So let's head over to the second sequence. The second sequence is the numbers 3, 9, 17, 27, and 39, plus some other digits that come after that. So we'll do again, we'll find the 4 differences between these numbers. So to start off with, we'll do 9 minus 3, which will give us 6. And then just going down the line doing the basic arithmetic, but making sure you take the second term minus the first term, and then the third term minus the second term, and then the fourth term minus the third term, so on and so forth. We'll get that we have differences of 6, 8, 10, and 12 respectively. So you see right here we have a second step. If we move on to our second step, which will be right here, we have to compare our values of D to see if there is a consistent difference or not. So in the case of sequence 1, we found that we have a difference of 4, 4, 4, and 4. That would mean that we do have a consistent difference and that this does have a common difference in this function, which would in turn make it arithmetic. In the second set, we actually do not have a consistent one because we have 6, 8, 10, and 12. Technically, you only need to have 2 differences be non-matching for this to be improper. So in this case, this is not an arithmetic sequence. And then this is just, bottom here just summarizes that. The common difference of this first sequence is 4, therefore this is an arithmetic sequence. And then there is no common difference, therefore this is not an arithmetic sequence. Alright, again, the problem we were given was to determine this. So right now, if you look at our problem, we've done the determine if the given sequence has a common difference, or that it's arithmetic, and we have done that. So we can quickly grab a pen and we can just write a big check mark through that we've done that half. Now what we need to do is we need to do this second half, which we need to find the 3 next terms. So to do so, we'll follow step 3 right here. We'll add the common difference to the last given term to find the next term. In this sequence, that comes out as our common difference again was 4 for this first sequence, and our last term we have is a 14. So we do 14 plus 4 to give us a total of 18 for the first term. And then the second term is 18 plus 4 again equals 22. And then we have 22 plus 4 is 26 for our next 3 terms to be 18, 22, and 26. Just a reminder, because the second sequence was not arithmetic, there was no common difference, and therefore we cannot actually find the next 3 terms of this sequence using the formulas given to us for arithmetic sequences. So to look at a couple of the problems that you guys have to do in class that are actually from the homework, I've pulled 1, 2, 3, 6, and 7. 5 or 4 and 5 are also related. It's more of a word problem though. It's a little simpler. It addresses each objective. It addresses both objectives but in a more simple way. So we're gonna look at these 2 for this. So the first type of problem that you'll have is to do what we did in the original problem. If you remember way back to here, we'll just jump back to that real quick. If you remember to right here, we had to determine if the sequence was arithmetic by finding the common difference. So that's actually what we're going to have to do for this problem again. So for each of these, you need to figure out if there is a common difference. So look at each of these 3 sequences and see if the digits from one to the next are the same. If they are not, then it is not arithmetic. So it's just kind of give you an example of what we're kind of looking for in this type of problem, especially for the explain your reasoning portion of this, which is a huge key. How you would go about doing that is you can kind of do arrows like this, and you just want to find that difference between those 2, between these 2, and then between these 2 at the end. How I like to do this is you can write out a little table, so we can write out we'll write out D on this column, And then we could write out like this is our work column. As sloppy as that is, trying to write with a mouse. We'll write that we have 3 minus 1, which is equal to 2. And then we have 5 minus 3, which is also equal to 2. And then 7 minus 5 is equal to 2. So the way that we know this is an arithmetic sequence now is because this D column right here. Let me grab another color so it's a little easier to see at least. This D column right here, if you look, all three of the differences are all identical. This is the same type of thing that you guys want to do for all three of these. If it turns out that, let's say that the problem number 3, they're not all identical, then it is not arithmetic. And then an important note for you guys just to remember is that this does not have to be a positive or negative difference. These can be negative and still count. So the second problem we have here is to, again, find the common difference of each of the sequences below, and then use that to find the next 3 terms. So this is 6 and 7. 4 and 5, again, are pretty related to that. So just for these, is what we want to see is we want to see this same work again. So just imagine we're taking this like whole thing here, and we're bringing it right down here, but just replacing it with these numbers to find our D value. And then remember what we're going to do here is to find D, what we'll show is it'll be like 22 plus D is equal to something, and then that value goes right there, and then you just repeat that a couple times, and then you'll have your 3 next terms. So just for kind of work, what we want to see for that kind of thing, again, is just show how you found your differences and then show how you found your next 3 terms. Even if it does seem like pretty basic math, we still want you guys to be writing it out because these are not always going to be basic. So if we return to our objectives, guys, for the second half of this, if you look on this list here at what we have accomplished, you'll notice that we have done this first part. We have determined if a sequence is arithmetic, and we also have found the common difference. And then we have found the next term, but we still need to do this last part down here. So we're going to venture into that right now, how we would find the nth term of an arithmetic sequence. So we have a secondary problem here, a secondary example to go over. So the problem example here is that we're trying to find the 10th term for an arithmetic sequence. The arithmetic sequence is as follows: 4, 11, 18, and then 25. And that continues. What we're trying to do is we're trying to find that 10th term, and we're trying to find it in a way without just finding the 5th, 6th, 7th, and so on terms and just going up until we have the 10th term. We can use that to check our work, but it's more, there's this general rule, if you look on the right here, that we want to apply. So to read off what this says to you guys, just to make sure that you guys get it, the nth term, also denoted as a sub n, of an arithmetic sequence is given by the following function: a sub n is equal to a sub 1 plus, in parentheses, n minus 1 in parentheses multiplied by d. So the important things to note here is just to watch out for, just make sure you guys write down this formula, you guys know it, because this is super key to this whole unit, this whole chunk of homework that we're going to do right now. It's also on the homework assignment, so don't feel too bad to you need to memorize it or anything, but it is on the homework there. And then just make sure you guys, we see that this is, we have A1 here, is our first term. So in this sequence, that's 4, and then D we'll find in a moment here. So the first step in doing a problem like this is to identify the components of the nth term formula. So to do that, I already started talking about that, but as we see here, we have this first term 4 here, which just goes right to there. We use n, we take the 10th term, so 10 is n. And then as you can see, we just kind of did the calculation for the difference again. I didn't do a whole table for it this time, just make it a little faster, but As you can see, 11 minus 4 is 7, 18 minus 11 is 7, and then again 25 minus 18 is 7, so we do have a common difference, which then means that this is arithmetic. To move on to more of the bulk of actually solving this, we move on to our step 2, which is to use this formula to find the nth term. So when we have this formula, we write out all of our variables right here that we found in the last one. So we found a sub 1 was 4, and then n was 10, and then d was 7. We then want to plug those into our formula, and we'll then find that a sub n is equal to 67 once we simplify. If you guys want, you can check your work with this too. In this case, I already did this, so I filled out a table of a sub 1 through a sub 10 here and here. And as you can see, 4 through 25 is the same as it is in our main sequence, but also we still got the same answer, 67. So we'll look at some homework problems that you guys will have in this section. So the first type problem that you can have, well, I guess the main type, I guess, is to find the nth term for any given arithmetic sequence as below. So these are written out in 2 different forms with some format for you guys. Basically what we want to see for these problems is we'll just actually do number 11 here. So I'll put a star there saying that we've done it. So the problem is the first term of an arithmetic sequence is 11 and the common difference is 4. What is the 10th term? So we need to use information. What we'll do is, again, we'll find that A1 is equal to, right here, 11. And then we have D is the common difference right there. So that'd be equal to 4. N is right here. We're asked what is the 10th term. So we got 10. I want to make a note here as well that these are not all the same terms if you look down, so just make sure you're not just putting 10 for n every time. And then we just need to use our formula here, which again is a sub n is equal to a sub 1 plus, in parentheses, n minus 1 multiplied by d. So then if we do the math on that, we would have 11 plus 10 minus 1, which is equal, and let me put my d in there too, not forget about that, multiplied by 4, which is equal to 11 plus 9 times 4, which is to 11 plus 36, which is not a plus, equal sign, if I could write today, is equal to 47, which is our final answer for that one. So this right here, what you guys are seeing is kind of just what we're looking for these problems. You know, you guys don't have to circle them like I did. It does help me when I'm doing this type of problem to circle it and then place it into each of these things. And then we want you guys to take this formula right here, a sub n, and solve for it. Pretty straightforward solving too, though. Just plug your numbers into the formula, and then simplify it down until you have a final numerical answer. And then I believe, if I remember correctly, this is basically the same for all 4 of these problems. The only thing you really have to do is change the term, and then for 2 of them, the common difference is actually negative. And it's also not given to you in 13 or 14, so you guys will have to practice your skills with finding the common difference again and again. Just make sure you guys include your work for that. And then just to wrap up for you guys, just remember that to complete the arithmetic sequences assignment that was handed out via the Blackboard week folder, and then also make sure to do the geometric sequences material. That's also in the folder. I believe it's going to be just below the arithmetic sequences section. And then there's also an exam this week, so just make sure you guys are doing all that stuff and make sure you guys are getting all that done.